Hello, my name is Gustav Seimer. I'm together with Mattias Nilsson Benfato, is one of the founders of Lexplore. We are both researchers at the Marianne Bernadotte Center at Karolinska Institutet, which is a medical university in Stockholm, which awards a Nobel Prize in medicine. The story of Lexplore and the research behind it started in 2014 when Mattias and I got our hands on an old set of recordings made of children in Kronoberg. These children had been followed up until today, and what we had available now, which wasn't available before, was using machine learning techniques to look at these eye movement recordings, and by using these methods finding out which children would have difficulties later and which would have not. Typically it's difficult to at one time know which children will have difficulties later, but here we sort of had an outcome which we could use to train machine learning models. The connection between eye movements and reading is not new. Even at the start of the century, eye movement tracking was used to try to understand the reading processes that goes on while reading. So by looking at the tracking or the pattern that eyes move while you read can be used to learn more about the internal processes in the brain. And even a short video recording or eye movement tracking recording of the eyes can tell you very much about what goes on with word processing and building up sentences and comprehension. It is very important to point out that eye movements themselves are not the cause of the reading difficulties. Of course, you need to have good vision to be able to read, but dyslexia or reading difficulties is at its foundational language problem foremost. But eye movement recordings give you a very good track record of how the reading process has proceeded, and from that information you can make a lot of insights into the child's reading development. Based on the longitudinal data from the earlier research projects, we developed our initial models, which were able to differentiate between children with reading difficulties and children without, with a very high accuracy, about 95%. Based on the recordings from the longitudinal dataset, we developed our first machine learning or AI models that could separate children with difficulties from those that have normal reading. These results were published in a PLOS ONE journal, and they for the first time showed that you could do this with very high accuracy and with a good balance between sensitivity, finding those children in need, and specificity, excluding those without difficulties. The results we published on the initial study was very promising for developing a screening method, but to actually prove that it would work out in schools, we decided to run a much larger project where we brought eye tracking from the lab out to schools and actually did screenings on about 3,000 children over the progress of 2 years. This data set is probably one of the largest at that time on children's reading using eye tracking, and it enabled us to get a much more concurrent view of finding children with reading difficulties in schools, and also developing the procedure for screening children in schools, which is both efficient and reliable. In this larger study, we of course didn't know which of the children that would later have difficulties with reading difficulties. And to get a concurrent view, we, at the same time as we did the recordings, collected or performed additional tests. And these were the usual tests you do when assessing reading difficulties. So we looked at non-word reading, we looked at word reading, we looked at word segmentation, and also rapid automatized naming to get a sense of their reading abilities. The results on these tests were then aggregated and used as an outcome variable to train models. And using this data, we could see that we could achieve a similar accuracy as we had done earlier on the longitudinal model or material, but this time on a much larger data set and on data actually collected in schools. The models we had developed on the larger data set were found to be just as good as finding children with dyslexia or reading difficulties as the earlier ones. However, now we also had a data set that enabled us to actually say something about all children's reading ability, not only just finding those with difficulties. So what we did, instead of predicting just if you have difficulties or not, we started to predict what your reading ability was compared to others at that grade level or at that time of year. Using these newer models, based on the percentile scores, it's possible, for example, to create reading groups or group readers on different levels, which can later be used to put in different recommendations. At Lexplore, we always develop our models, or continuously develops our models, and we use scientific processes during this. For example, when we go into a new language, we typically collect quite a lot of data from different age groups and use these to adapt our models or develop new ones. In similar, when we go into new grades, we also collect data, and we also use the recordings that we have done to improve the models over time. We do this with other researchers as well. Current examples is our collaboration with the University of Memphis, where we have done a study together on children in California, where they read using Lexplore, and they also did other traditional tests, and we also looked at their state end of year tests. At the University of Memphis, they also did a running records analysis to assess their children's reading ability, and we can see that our models agree to a very high degree with those results. The process of using running records and the way we do these new models also enables us to move into other markets faster than we were able to do before. At Lexplore, we are firmly based in the science of reading, and this perpetuates not only when we develop models and provide results, but also in how we develop our testing procedure and application, but also support material used by children and teachers. We rely on phonics for instruction of learning how to read, and we are up to date with latest developments. We are also assured, for example, by the British Dyslexia Association as one of the providers of assessment and materials that they approve of. If you're interested in more of the science behind Lexplore and our research, please read here or reach out to us.